I showed you this when we did our other project, that engineering design process. So let's check in, see where we are in the engineering design process. We identified a problem. We said, hey, we've learned about first changes over time, and so why don't we make a book, okay? Word problem doesn't always mean something bad, okay? Just might mean a challenge. We identified the criteria and constraints. Didn't I give you some guidelines?
Yeah.
And then you created your groups, and then within your groups you gave each other, you gave yourselves some guidelines, correct? Who was responsible for what? Then we brainstormed some ideas. Each of you had your assignment, you took your page for the pop-up book, and you came up with some ideas. What do we call those ideas, those brainstorming ideas? What were those 3 things we had to turn in? The first one was really rough.
Final draft.
We had rough drafts, then we made a second draft, and then we made a what? The final draft. We just kept that revisiting and generating and exploring more than we could do, okay? Until we are now, if you stayed with the timeline and you've turned in the assignments as they were given and as they were due, then now we're right here at step 7. We have our final plan, and now it's just time to execute the plan. And the first part of executing the plan is to build a prototype or build a model, okay? Now, it's going to be difficult for you to not think about the pop-up mechanism, but I'm going to ask you repeatedly today to not concern yourself with that, okay? What do I not concern myself with?
The pop-up mechanism.
The pop-up mechanism. Do not worry about how it's going to pop up today. We'll take care of that. Today, all I want you guys to do is to build a prototype. Can anybody tell me, what is this word prototype that she speaks of?
We made one for the hot air balloon.
We made one for what?
The hot air balloon.
For the hot air balloon, didn't we? We made a prototype, smaller version. Only this time, we're actually going to make the full-size version. You guys ever seen, they're really cool, these car commercials where the engineer is actually building a car out of clay. Have you guys ever seen that?
Yeah.
And they're like molding it, and it's so cool. It really looks like a real car, only it's made out of clay. You know, the engineers that design cars, they actually do that. Why do they do that?
So they can see what it looks like and what it should look like?
Mm-hmm. Well, why don't they just build a car?
Because there could be some problems
To
that,
plan.
that should have been identified earlier that could cause some really large effects later.
Okay, could be some problems that need to be worked out. What would be another reason they would do that car out of clay as opposed to just building an actual car?
Clay is a lot less expensive than like actual materials.
Does that make sense? The cost of materials? Okay. What else would be something that would be costly? What else would we be giving up if we made it, out of its actual materials versus, maybe a less expensive?
If you messed up, all that material goes to waste.
All that material goes to waste, and all that what? Time. Okay. But time it's nice if it's well spent in this planning, right? So today what we're going to do is we're going to make a prototype. Only it's not going to be a scale model. It's not going to be smaller than, and it's not going to be larger than. You're going to create your scale model as close to the actual size that you want it possible. Okay? So what you're going to do is you will take your design page. Let's get a piece of paper from over here. So you're going to take your final design. So let's say this is my final design, right? And what is your model going to look like? Your pop-up feature, what is it going to look like when your page is open? Okay, so I've got my 11 by 17 page, it's open. What is that model, that feature going to look like in its upright, popped up position? That's what you're building today. I don't have to worry about how it's going to get to that position. That's not my concern today. My concern today is just making that model the way I want it to look on that page in the popped up position, okay? It's gonna have to be 3-dimensional. It's gonna require that you really think about it, okay? And one more thing before we actually go ahead and get started, and that is my Magdalene story. Today, Magdalene was sitting over there after I gave the instructions. Everybody peeled out and they started working. And Magdalene, she was just sitting there, and she was just mad. She looked like somebody had killed a dog on purpose. I was like, I don't know if I want to go over there, but I had to, right? It's my job. So I went over there and I was like, Magdalene, what's the deal? I don't know how to make my prototype look like I want it to look when I make my book. And if you guys have ever heard Magdalene when she's mad, she growls, doesn't she? He's been on the receiving end of that. She growled at me. I was like, whoa, you sweet looking little Magdalene. And she just let me have it. I'm like, well, Magdalene, that's exactly the point of today. And of course, she was not happy with that answer, now was she? And she just looked at me with a growl. And I said, well, what I mean is, this is the struggle part. Remember when we made our hot air balloons? And I said, whatever design you want. And there were people who made pigs, right? And I had people who made Minnie Mouse and people who made pineapples, all kinds of different designs. Then it came time to actually construct the balloon. And was that hard or was that hard?
That was hard.
That was hard. But what did you have to do?
Work through it.
You had to work through it, okay? Well, we're there now. We're at the difficult part for the pop-up book now. And what are you going to have to do? Work through it. This is truly trial and error, okay? So, I mean, you guys know who Edward Scissorhand is?
Yeah.
So I should see some Edward Scissorhand, and you guys are just trying to work through making a 3D model of what I want it to look like. Not concerned about what? Pop-up mechanism. Only thing I'm concerned about is what is my model going to look like. Then we're going to take your prototype, and then we'll figure out from there, from that constructed, popped up version, then we'll figure out how can I get this to collapse and how can I get it to pop back up. That's the next step. Let's do this step first. Okay?
Okay.
We all right? Okay, so for that, then, what do you need out?
Paper, scissors.
You need, what's the first thing you need out? Right, because we said we had our plan. So the first thing you need out is your plan. The other thing you're going to need, so I have my plan folded out, and this is, you guys will be at your workstations. I'll need my plan out. There's some computer paper at your tables, and I'll come by and I'll restock. And that's what you're going to use to actually make your prototype, okay? Oh, by the way, Magdalene was the first one to have a completed prototype. And it was beautiful. Once she realized it was okay for her to fail, try again, fail, try again, fail, try again. Ah, success, okay? She had a beautiful volcano. One side was a stratovolcano, and then she had this kind of pie cut piece, and on the inside you could see all the parts, you know, the anatomy of a volcano. As soon as she realized it's okay, I can mess up. That's part of the process. Don't I tell you guys that?
Yes.
Okay?
Yeah.
All right, so we're going to go to our stations. Here's the rule. You can roam. That means you can walk around your table, but you may not go where?
Leave your
You can't leave your table and go where?
to other people.
To other people's table. If you have a question, who should you ask? Your group first. Thank you, Gabe. And then
The teacher.
me, okay? You ask your design team first. That's why you guys are in a team, to help each other, okay? And then me, and there's materials at your table that you can use, okay? Questions? Comments? Concerns? All right, so he has a me question, not a we question. Any we questions? All right, move out. Okay, time out. Let me. So right now, this represents the house, but now it's time to build the house, the size, the shape, the dimensions that you want.
All right.
Okay.
All right. How am I supposed to do 2 things on?
Wow, that's the struggle now, isn't it?
Yeah.
Okay. How about you work on it and call me over and I'll check your progress, okay? Well, you know what? It's just as tough for me because I really want to say, oh, all you have to do is, but then, are you learning anything?
I feel like if we make it, hold on, go like this, like hold on. Make it like that. Get it? Only I can see it. I'll show you what I mean in a second. And you could go, I see how big it is on this paper.
What's up, Nick?
It's like that way.
I've written, I'm not finished yet.
Should I get?
I know, you just have the gift of writing, I tell you. You write and write and write and write, but where's
I did everything that you told me to do.
well, where's the pop-up feature then?
Well, I'm not that
Maybe
good at
not
it.
quite everything.
I'm not that good of a drawer.
Did I say I want to see a beautiful Picasso on there? No, I just said I want to see where your pop-up is, what represents it, the amount of space it takes.
So let me add
You're
some
gonna
stuff.
take care of that and then call me back. I appreciate that.
Is it okay if I don't do like a rectangle and I do like a dome with like a slider part of it instead?
Whose page is it?
Is on page.
So,
I can. Okay, and then I have one more question. How many wheels do we have to have? One or two?
what do your guidelines say? Where's your iPad?
You're doing
So I'm doing that.
right, and then this was my page, right?
You have to do the.
This was my page.
Okay, what
Yeah.
page is
Yeah.
141.
So this is the multi-material. I'm pretty much
So
drawing
ours
whatever.
is kind of different. I mean,
Okay, so this is my
Just do the face. Just do the face.
Wait, no, sorry. Was it?
That's gonna be kind of rounded.
I mean, mine's like erupting. Yours is like.
Wait.
Is the multi? Do you guys think the multi-material should like come up?
Yeah,
Make
okay,
the
so what I
orange.
think what should happen is you know how you have like so the actual like thing will be like this. And so when it's compressed down,
Oh, hey, look.
see it?
Oh, wait, no, that's our
Whenever these two like go this way.
Yeah, it'll have
Like,
room to
up.
go up. Yeah, and I think that
Okay.
as long as these, as long as these
Those
holes
pulls
here are
go
long
out.
enough to the point where it can actually
So
pop.
this.
are you doing?
Yeah.
Nothing's on that side.
Well, you're gonna have to decide.
I think we might need it
Okay.
though.
That's, you know what this is? This is all of this empty space that you need to take care of. Okay?
Yeah, but like I don't know what to put there.
Yeah, paper.
Where? I need a microscope to see it.
I can see it.
Okay, I'll give you a Band-Aid for that gusher. Thank you. Okay, all right. So what you can do is you can split this and have one here and one here. No, this is a wheel, this is a wheel, but half of the information's in this one and half of the information's in this one. And then I can move this up here. But those are decisions that guess who has to make.
Our group.
Whose page?
Well, way to be a team player. This is so hard.
Pretty good at it.
Hey, you gotta work through it, Lindsay.
All you need to do is
Mackenzie, if you really want to quit,
door
I'll
on and you know.
No, there's no quitting. Be a team player. There's no quitting in STEM.
And then Alfred Wegener will be like standing.
Yeah, like Abe Lincoln and Mrs. Rubens.
Like that.
Figure out how to do it.
This is too big of a sphere. Dang it. Smaller sphere.
All of this means,
Somebody who studies this.
so someone who studies Earth. Now, your pop-up doesn't have to be restricted to a plate. Can it be the person who studies the plate?
What are you even doing?
Be like, what are the plates made of? The crust and?
right there.
No, that's what moves them. But what is the plate made of? What are the plates? Stop, think, because you're guessing right now, and you know this answer. What are the plates, tectonic plates made of? Crust and? Help me,
The
teammates.
first 100 kilometers in the
The first, it's called together called the lithosphere. That's right. Crust and first 100 kilometers. So why can't you make that?
Yeah, I can do that probably.
I think you can. Okay, so what I want you to do, I want you to draw it right here. Okay. First step.
Okay, because I want the background like to be red already, and then so I was gonna have like the volcano right there, and then so it could just, and then I could like just draw in some red, so you want to like see all those white spots.
Okay, I'm sorry. thought you said this was a magma chamber. It said volcano.
The magma chamber.
Oh, okay. I was like, I didn't know. Okay, so don't forget to take the red pass out of the blue crate.
And then so like I don't know how to like make it seem like that, like the magma is like flowing out of it.
Okay, now, but this is a magma chamber. What direction does the magma move in a magma chamber? Up. Okay? So you don't need to make it flow out because remember this is all underground. This is a chamber. You've heard about the queen's chamber is her room, right? A chamber is a space, a closed-in space. Okay? So this is a magma chamber, so it's a space that has magma in it. So, are you trying to say I want to show that there's magma in there? Okay, without it flowing out, because we don't want that because it's not a magma chamber. And that's what I was saying about keeping this side kind of lower than the other side. Okay, so if I kind of like maybe just cut just that little bit out, and I cut this a little lower, then you can see the magma in there. You may even be able to take a piece of paper, color it all red, and I put it in there like this, right? Then I can see the magma in there. Do you know what I mean?
Yes.
Okay. Like right now, I can see a red bottom. We'll raise it so I can see more magma.
Okay.
Does that make sense?
Yes.
Okay. Let's do that. Okay. Yeah, we're good.
Scraps right here. Okay, so. Okay, try to make this smaller. Look now, now does this work? No. This better. Wait, let's see if I can do this. Is this gonna work? Miss Penner!
You're way over there.
You never know. You're right, I never know. That looks pretty sick, right? We're gonna make 3 more of those. How's it going? Too good. I don't want to do. You should make a half dome like he is. Half domes are always good. Yeah, I love half domes. Half domes are great. Half domes are good. Half domes are great.
Hey, Nick, Cardinals fan anybody?
Wait, I'm about baseball right now.
So now you would
So how do you make a half? Where's the doing that? How do you make a half dome? Like a half dome? You do like, you make a bunch of things like this,
excuse me? Nick, go ahead. Move away.
you know? And then when you cut it back, you like put them together. But you gotta make them like the same size.
So we have Pangea here, and then present day is going down here. So you can, your reader can compare the two.
Yeah, and then I have like a little fan. Like,
can I ask you-
with a flat glass.
Well, what about, what is this going to look like?
That, probably like
You could just make it blue.
blue. That's what I'm probably
That's basically what the rest
And that's exactly, because all of the land is concentrated here and everything else is
So you could use like some construction.
right. So I just want you to think about that.
Okay.
Okay?
Yeah.
Today's work would be a little bit of a what?
Challenge.
A little bit of a challenge. How many of you guys felt that? Okay, see? As promised. Okay, let's hurry up, Art.
Alright, okay.
But how many of you felt like as you struggled through, things did become a little clearer? The fog started to lift. Okay?
No.
And how many of you feel like, well, I said started to lift, not that the skies were clear and you could see everything clearly, but the fog is starting to lift, correct? and I can actually see something actually happening, right? And I mean, I saw several light bulbs, but I think the biggest, brightest one was when Anna was like, "Oh, I know." All right. So what we're gonna do tomorrow when we come back is people who feel like, okay, I'm ready to share how I made my breakthrough, because I was struggling. Because she was over there. She wasn't her usual smiley self, right? And she struggled through, but she had a breakthrough, and so we're going to share. Alana did the same thing. Her volcano would not flatten out, would it?
No.
Okay, but she had to come up with, okay, how can I cut this paper so it will flatten out to the shield volcano that I want? It just keeps making a cinder cone, okay, and that was getting on her nerves. So we're going to talk about that, how to make something curve, right? Right?
Oh, yeah.
Right? How to make that globe shape or half of a globe, okay? We'll have Natalie share how she made, mountains and water, and now she's going to make clouds, okay? How we break through those. A lot of you had to make cubes. Ethan was making a cube, and he was cutting all of his top, bottom, each of the 4 sides, and then we kind of had a breakthrough on, I don't have to do all that cutting, and it makes it a whole lot easier, okay? If I just do the folding, okay? So we're gonna continue. She's like, oh, that's right.
I already have done all the
always works in
all
those.
of my it's not even worth trying to do.
But you just had a breakthrough moment. Then you go, oh, okay. So tomorrow we're gonna pick up with this, okay, and we're gonna finish up our models, our prototypes, okay. What we need to do before we get out of here, we have 2 minutes for what? Stools and chairs. Let's do it.
When I'm doing 1 and 2, you do 3 and 4, and then Jackie, you 5 and 6.
Okay, so all we have to do is find the answer. You guys can cut to the directions.
I should.
Swipe 4. Swipe 4. So I'll do.
Okay.
You do 1 and 2, and I do 3 and 4. Okay, I got 3.
Equals 3.
It said change the card, and I changed the card, but that worked.
And then you go to. I know. We chose the geometry. We think that looks best. What goes with fraction?
I've got it, guys. You're back and working. This is my
This big old. And this is my everything's oh, that's good. I was using it. Let me 2, 1, action! Today we will be making or adding 2 fractions, 6 3/4 and 3 and 7.
God, you said adding or subtracting.
Okay.
Go back, delete the little.
No, we're supposed to be doing an adding problem and a subtracting problem.
But first,
And subtracting.
First
so
one
we have to
first?
write 2. Just say today we will be adding and subtracting fractions. First we will be subtracting 6
okay, that's perfect. Perfect. Let's do it. 3, 2, 1, action.
Today we will be adding and subtracting fractions. First we will be subtracting 6 3/4 and 3 7/8. Let's see. So first we take the proper fraction 6 and 3. 6 minus 3 equals 3, and then we'll be putting this into simplest form, or making this bigger, and putting that and converting that to an 8, converting this to a 6. 7/8 minus 6/8 equals 1/8, and in the end it equals 3 and 1/8. So that's how you subtract fractions.